I am so excited about this next project and I can't wait to get started. Today I want to show you how to build your very own FPV 250 mini racing quadcopter. Now you may ask yourself, what is FPV anyways? FPV simply means first person view. So on the racer itself we have a camera and then we're going to be able to fly it using immersion goggles as if we were in the quadcopter itself, which is really cool. In this build, we're going to use the ZMR 250 carbon fiber frame, the Fat Shark immersion system, and the Open Pilot flight controller. But just before we get started, I'm totally amazed at the size of these little 250 racers. Here's a 250 racer, and when you see it in comparison to a 500 mil quadcopter, it is quite a difference. Also, I want to thank our sponsor, Eurodrone.com, for helping make this possible. So anyway, let's get started. So this is our ZMR 250 mini quadcopter frame, carbon fiber. And you can see here that I've gone ahead and I've assembled it this far just in the interest of time. But before you go ahead and assemble it, one of the first things we want to do is enlarge this hole here just by a couple of millimeters so that we can pass through a battery connector, because on our racer what we want to do is mount our battery on the underside of the quadcopter to maintain as low a center of gravity as possible. That being said, on one of your bottom plates, go ahead and pass through your Velcro battery holder, and then on your other bottom plate where we have our standoffs mounted, we want to secure the threads of those screws with some Loctite blue. This is the removable kind because they're not easily accessible if they happen to vibrate loose. So we want those to be nice and secure. Also, once we have this hole enlarged on the back, you want to identify the front of the quadcopter frame. That way we don't get things back to front, because not only are these two bottom plates identical, but from here over, from the center line over, they're symmetrical as well. So it'll be easy to mix it up, and then in assembly you realize, oh, wait a minute, the hole that I enlarged I've got back to front. So you want to just save yourself a little aggravation and mark off the front of the frame. Also, what you want to do is go ahead and take the top plate and mount the vibration damper with these 4 rubber grommets. Once you do that, we can set it aside until later on in our build. This little piece is just a camera frame where we'll mount our camera behind that, and it just adds some protection to your camera if you happen to get into a crash. Also, what I want to show you is when you mount your motors, don't put the blue Loctite on these motors. What you want to do is turn it over and put some duct tape over the mounting screws for the motors, so that if they do vibrate loose, you're not going to lose them in a field somewhere or on the racetrack somewhere. Okay, so what else do we want to do? Oh yes, we want to identify our motors, this being M1 clockwise, and go ahead and mark the frame. This being M2 counterclockwise, this being M3 clockwise, and this being M4 counterclockwise. If we do that right at the beginning, and that's a habit I like to do, then it gets easier as we get into the flight controller, the ESCs, and then configuring it later on with the Open Pilot software. Here's what our power distribution system looks like for our quadcopter racer. And when you assemble this, it's best to envision it being mounted within the quadcopter frame. To help you do that, just take some masking tape and mark off the front, your M1 motor, your M2 motor, your M3 motor, and your M4 motor. Now, the way we've numbered this, M1, M2, M3, and M4, is the same as what we're going to encounter in the OpenPilot software when we go to configure our quadcopter. So to assemble this is very, very simple. You just take a power distribution board. Here's our connection for our battery. And then you'll see here I have an extra set of wire leads in case I want to mount something later on that requires power, like LED lights, for example. Then I don't have to take it all apart. I've already got it soldered to my power distribution board. So in the meantime, I'll just put some electrical tape on the ends and then curl it up and tie it up neatly inside the quadcopter. Also, your ESCs, it's a good idea to identify them as well and mark them the same as your labels, M1 counterclockwise, M2 counterclock, or M1 clockwise and M2 counterclockwise, etc. Because as you're assembling everything, it just makes life easier. Also, the servo leads that go from the ESC to the OpenPilot flight controller, we want to mark them as well. So this one will be 1. Just mark them, identify them with a Sharpie marker. This one will be 2. This one will be 3. And then this one will be 4. And it makes life that much simpler when we attach them to the flight controller. Now, the only thing you really have to watch when you are assembling your ESCs to your power distribution board is that you keep the positive and negative straight. Red being positive, black being negative. And that's basically it for our power distribution system. It goes together very, very quickly. And then mounting it in our frame, which we're going to do right now. The back of the power distribution board, I've put some double-sided tape, which will hold this nicely in place. And we'll just go ahead and center it between these 4 standoffs and set our ESCs straight. And then we'll push our battery connector through to the underside. And we just want to make sure that our wires are on the inside of our standoff posts. Like that. And we're just going to take a little cable tie and lightly secure each of our ESCs in place. Now when you do that, don't over tighten your cable ties. Just want to tighten them enough to hold them snugly. You don't want to damage any of the electrical components on the inside of this shrink wrap tubing. That's all it is some shrink wrap tubing around the circuit board. And we'll just clip off the excess. Alright, so now we have our power distribution board in place. We've secured our ESCs. Now the next step is to add our OpenPilot flight controller. Now this is on this side is the harness for the input, and that'll connect to our radio receiver. One thing that you want to be very careful about, you'll see I've already marked this with an arrow. Hopefully you can see that in the video. But the arrow points this way because the flight controller board actually has a front to it. And I've seen quite a few videos of people building quadcopters, and they have, you know, the board mounted this way or the board mounted this way, and it's actually mounted incorrect. Each of the boards have a small little arrow. Now you can't see that inside this yellow case, but they have a small little arrow that indicates the front of the board. So I've gone ahead and I've marked the outside of the case with the arrow. This arrow needs to point to the front of the quadcopter. So if you're following this build, your output pins, this is where we'll connect our ESCs, need to be on this side. Your receiver needs to be on this side, and your USB port points towards the rear of the quadcopter. So now I'm just going to mount this right on top of our power distribution board using some double-sided tape. And it mounts right nice. Mounts nicely right inside our soldered connections on our power distribution board. Now that we have this in place, we can go ahead and connect our ESC servo wires, and this will go quite quickly because we've already identified each of the servos as number 1, and that's going to plug directly into the number 1 output set of pins. And our orange wire on this particular ESC, these are Simon K ESCs, on this particular one, our orange wire is our signal wire. So it's going to be orientated. You can see, if you look very closely on your board, that not only are the pins marked 1, 2, 3, 4, 5, 6, etc., but they're also marked this way, so that here's your signal, and then your positive, and then your negative. So the yellow or the orange wire on this particular set of ESCs is our signal wire. We want to make sure that's on our signal pin. So now I'll take ESC number 2 and connect it onto port 2. Again, our signal wire being on our signal pin. Then I'll take ESC 3, connect it to number 3 on our output pins. The orange wire on our signal pin. And then I'll take our ESC number 4 and connect it to number 4 on the output pins with our orange wire on the signal. Wonderful. So you go ahead and do that, and while you're doing that, I'm going to bundle up these wires just to clean them up a little bit before we proceed. Alright, I've bundled up our servo wires for our ESCs and our extra power lead wire. Now we can go ahead and we can connect the wires from our ESC to the motors, to the wires on our motors. Now there's a couple of things that I want to say here. Is number one, if you need to strip back the wires on your ESC or on your motors, do that away from your motor. You don't want any little wee strands of wire falling down into the motor and getting stuck in the magnets, or you could end up burning out your motor or your ESCs or both. So any cutting and stripping of your wires needs to be done away from your motors. And if need be, you can always wrap your motors with a little plastic sandwich bag or something like that if you feel a little bit nervous about doing that. So I'm going to connect these wires, and it doesn't really matter which three wires go to or which combination of wires you connect, because we'll sort that out when we're configuring the quadcopter in the OpenPilot software. So just make sure that you connect each wire from the ESC to a wire on the motor. So in the interest of time, I'm going to go ahead and do that, and I'll be back in a minute. Alright, so now we have our wires connected from our ESCs to our motors, and the only thing you want to really make sure of, don't go ahead and solder these just yet, because when we configure this in the OpenPilot software, we may have to switch any two of these wires around, and you don't have to worry about that because you won't hurt anything so long as none of these wires touch. Now we can go ahead and hook up our radio receiver, and we're using the FlySky. We're using the FlySky FS R6B. It took me a second because I had to slip on my glasses real quick. So the radio, I'm going to show you the wiring sequence that we used. We're going to take the 3-wire, which is the white, the red, and the black, and we're going to put it on channel 1. You don't have to be too particular as to the sequence of the wires, because the radio wizard in the software is going to sort a lot of this out for us. But we already had this hooked up once and working very smoothly, so we'll just go ahead and do what we did before. So the white wire on the signal pin for channel 1, and then the blue wire we put on channel 2 with the wire on the signal pin. And then we put the chartreuse wire, which looks very, very close to the yellow wire. We put that on channel 3 with the wire on the signal pin. And if you find I'm going too fast, or you can't see this as clearly as what I would like you to be able to see it, then visit our website, learnrobotics.com, and that's robotics with an X. And there's detailed web pages and photographs and step-by-step instructions for this entire build as well. So now we'll take the green wire and put it on channel 4 with the wire on the signal pin, and then the yellow wire on channel 5 with the wire on the signal pin, and then the black wire on channel 6 with the wire on the signal pin. don't put any wires on the one that says BAT. We only want to use that to bind the radio receiver with the transmitter later on. Okay, so now I'm just going to take this and set it aside, and I want to show you the Fat Shark FPV system, and then we'll mount the receiver and the Fat Shark system onto our quadcopter frame. So I'm going to set that aside. And the Fat Shark system is actually an entirely separate system from our quadcopter system itself, from the flight controller and the ESCs and the motor. So it consists of a transmitter, and this is actually what this little component is a noise filter, so that it helps eliminate noise from the battery and eliminate static in your goggles. And it's equipped with sockets for 2S, 3S, and 4S batteries. And then we have our camera. Now I'm just going to put a little bit of power to that, just so that you can see if everything is working properly. A red LED will show up, if you can see that. A red LED will show up on the transmitter. Now, a word of caution. Never put power to this system without an antenna. Otherwise, you'll burn out the amplifier. So that's our FPV system. Let me just disconnect this here now. Set that aside. And I want to show you what we did with our camera. With our camera, I'll come close to the, let me just disconnect that and set that aside. You'll see what we did was we epoxied some wire to the camera itself. So we just put a little epoxy on the top and on the sides of the camera to hold this wire in place. That way we can fit it into our quadcopter frame, but then we also have the flexibility of changing the angle until we find an angle that we're comfortable racing with. Then we also put a little bit of double-sided tape on the bottom, number one, to help in the installation, but number two, just to add a little bit of dampening for the camera itself. Once we find the angle that we want to race with, then what we'll do is we'll mount the camera itself in a bed of silicone caulking. So the silicone caulking, you know, for caulking windows and stuff around the house, the silicone caulking will work nice for a bed for mounting our camera, rather than using hot glue or 5-minute epoxy, which will make it very difficult for us to remove the camera if we have to. So let's go ahead and get this mounted into our quadcopter frame. So let me move this sticky tape here. We'll put our little camera frame in place. It just fits in those slots. And then the first thing we want to do is mount the camera and just feed the wires through the frame. And then we'll twist it tight on the opposite side of the frame. There we go. that in place now, and then fasten our camera. Into position, like so. Now it's a little bit of a radical angle at the moment. That's okay, we can adjust that a little later on. Now, what we want to do is just disconnect this wire, because we're going to feed that through the frame and bring it out in the same hole that we modified for the battery connection. But one thing that I want to point out first before we do anything, with the transmitter, you're going to notice there's a little box here where the power wires come in. There's a little box here, and it has several dip switches. The transmitter itself is covered in a protective plastic. Just take a razor blade and gently cut that out and then remove the plastic that's on top of those dip switches. The reason that we're doing this is that if you're racing and in close vicinity to other racers, you may have to change your channel, which is likely, and to do so you have to do that by flicking one of these switches or several of these switches on or off. And if you're at the racetrack, it's going to make life a whole lot easier if this plastic is already removed for you. So now we'll just mount the transmitter to our top plate using a couple of cable ties. Really is a nice frame for mounting components and working at assembling things. So we'll just put that there, run this one through here like that, and then up. Like that. Don't over tighten things, just make them snug. Okay, and then this power wire, we're going to feed down through that hole that we modified, because the little filter is going to mount underneath because it needs to be close to the battery. But what I have found is you can get these extensions for the balance lead of your battery, which would allow us to mount it anywhere we want inside of the quadcopter rather than underneath. But mounting it underneath works well too. So now we can hook the other end to our camera. And it just plugs into the back of the camera real easily, like so. And then our radio receiver, we're going to mount to the bottom side of our upper plate, the same as what we did with our Fat Shark transmitter. But what we want to do is feed the antenna through that hole right there. And later on we're going to make a little straw holder for our antenna. And then we just fasten this in place. When you do that, just trial fit things to make sure that you have enough clearance for the transmitter and the other components like your flight controller, your wiring, which we do nicely, like so. So let me tuck these wires up inside, like that, like that, and then we can fit this in place. So for now, what we'll do is we'll just put a couple of screws, because later on we need to get at that USB port. So we're just going to put a couple of screws in here to hold that plate together. Or to hold our upper plate onto our frame, and then fit our camera frame in place. So I was saying we would mount this antenna inside of a straw like that, and then we can epoxy that straw in place to keep our antenna upright for the best reception. One thing you don't have to worry about with the radio reception and the Fat Shark immersion system or your FPV system is they work on totally different frequencies. Your radio being 2.4 and your FPV system is on 5.8. So they're on two entirely different frequencies, so they won't ever conflict with one another. So now we'll turn this over, and let me just get our blocks like this. It's a nice little mechanic stand like that, and we'll mount our power filter underneath using a little bit of double-sided tape here. Like that. And then we'll be using 3S batteries. So we'll put the 3S side towards the front of the quadcopter, and then we'll just simply put our power lead back in, like so. And we have enough room if we put our battery there. Velcro it in place for the time being. There we go. Here's our mini quadcopter racer. And what we did is we made a nice little body out of a soda bottle, and you can look on our video channel or on our website on how we make these out of a soda bottle. But it just has some double-sided tape on the bottom, and that will fit over our antenna like so, and then down on the bottom side of our frame, like that. Alright, so now we're done the initial build. I'll take this off for now and set it aside because we have to take the top off anyway to get at the USB port when we configure our quadcopter with the OpenPilot software. So that's it for now, and we'll see you at the computer.